Hello and welcome. Today, we're diving into the exciting world of solar energy, specifically looking beyond the familiar silicon panels. Materials science is buzzing with innovation, developing new materials that could revolutionize how we capture the sun's power, making it cheaper, more efficient, and more versatile. Leading the charge are materials called perovskites. You might not have heard of them, but in labs they're superstars. Imagine a solar cell technology jumping from just a few percent efficiency to over 26% in about 10 years. That's perovskites. They rival traditional silicon, but offer unique advantages. They're often cheaper to make, using fewer steps and lower temperatures. Plus, they can be lightweight and flexible. Think beyond rigid rooftop panels. Solar cells integrated into building facades, car roofs, maybe even your backpack. But there's a catch, or rather, a few challenges. The main hurdle is long-term stability. Many perovskites don't like moisture, heat, oxygen, or even strong sunlight. They can degrade over time, losing performance. Another concern is that the top-performing perovskites often contain lead, which raises environmental questions. Scientists aren't giving up, though. They're tackling these issues head-on. One way is through compositional engineering, carefully tweaking the chemical recipe, swapping elements in and out to find more stable and efficient combinations. They're also working hard on lead-free versions, using elements like tin or bismuth. Another strategy involves using special additives or applying protective passivation layers, almost like a microscopic shield, to fix defects and boost durability. Even modifying the crystal structure itself or engineering the interfaces where different layers meet helps improve performance and lifespan. And of course, robust physical encapsulation, sealing the sensitive layers away from the environment, is crucial for real-world use. One really promising approach is creating tandem solar cells. This means layering a perovskite cell on top of a traditional silicon cell. Why? Perovskites are great at absorbing high-energy blue light, while silicon excels with lower-energy red light. Together, they can capture a much wider slice of the solar spectrum, potentially pushing efficiencies well beyond 30%. This is a powerful way to boost existing silicon technology. While perovskites get a lot of attention, the innovation doesn't stop there. Research continues on advanced thin-film materials like CIGs and kesterite, offering flexible alternatives. Organic photovoltaics made from carbon-based polymers are light, bendy, and potentially transparent, ideal for integrating into buildings or even wearable tech. Then there are quantum dots, tiny semiconductor particles that can be tuned to absorb specific colors, theoretically offering very high efficiency. We're also seeing early research into ferroelectric materials and entirely new forms, like solar paints, transparent window coatings, and even solar fabrics. The future of solar power looks incredibly bright thanks to these materials science breakthroughs. Researchers are pushing the boundaries to not only increase efficiency, but also make solar tech more durable, affordable, and sustainable. Overcoming the current hurdles for these next-generation materials will be key to unlocking wider solar adoption and accelerating our global shift towards clean energy. Thanks for tuning in.